Hello. Yeah, thanks so much for joining in, everyone. Thanks, Ajay. Thanks, Anita. Thanks, Neha. Thanks, Vijay. And people who are joining us on our social channels, Prashant, Sushmita, thank you so much for joining in, right? So in today's session, I'm going to also talk about our current module. And also I'm going to welcome a few of our new members who have joined, right? So let's proceed. In previous sessions, we have learned about regression, but I'm just going to guide on how new members can take the most out of it, right? How they can make the most out of this particular session, right? Okay. Hello, Raja sir. Great. So let me go ahead and share my screen. Okay, let me know when you're able to see my screen. Okay. So when you access your Teachable, so this is how your Teachable will look like, right? So people who are in bronze and the Teachable will have different structure, and people who are in silver, that will be different. But now to give you a clear idea on how to proceed forward, people who have recently joined, Saji, Nihar, and Raja sir, right? So what you can do is you can start from the beginning, right? So you can start from the Python basics refresher, go for EDA, make features, right? So all of this, you can see that the lecture, the first module will be the actual lecture, and post that there will be little quiz and assignments, right? I hope this is clear. I hope everybody has got access to their Teachable, right? So if you are able to access your Teachable, type T in the chat box. Okay, I am going to answer that question. So if you are able to access your Teachable, the new member specifically, type T in the chat box. Okay, Saji. Great. So anybody else who want to put? Thank you, Raja sir. Thank you, Neha. Okay. Now, Saji, I would request you to check your emails, right? So in your emails, you might have received a mail from j@pixeltests.com or Teachable, right? So you can search from on your email. Then you'll see an option to access course. When you click there, you'll be redirected to creating a account, right? So that is how you access it, right? So Anita ma'am, I hope you are able to access which module you are in, Anita ma'am, like from the beginning, which module you are in. Saji, if at all possible, you can do it parallelly. Okay, Anita ma'am. Yes, Raja sir. Okay, so I'm going to continue. So that is how it is. The revision hackathons, the format of revision hackathons is in this way. We are going to cover from beginning, and in one cycle, we are going to finish all of the lectures from each of the module. Third module lecture, 0.1.
Yeah.
Okay.
Miracle.
Okay, so I request the new members to mute. Right, thank you. Yeah, so we will be going in that particular fashion, right? So if at all in the initial few lectures, you get the reference of Canvas, right? So you can safely ignore that. Canvas is an LMS which we were previously using, right? Right now we are on this school.pixeltest.com or Teachable, right? So all of that was there in Canvas is currently now on your Teachable, right? So all the assignments there are here, all the quiz that is there is here, and more options are present in your current access, right? So when you're accessing your sessions, if at all you go through the Word Canvas or the LMS Canvas, you can safely ignore that. I hope that answers your question, Raja sir. Okay, yeah, Teachable is everything is there here, right? Now the people who have recently joined, I hope this is clear. You can start from the module 1 and continue And you can also join the revision hackathons, right? So the revision hackathons that currently for this cycle I'm taking, many facilitators will also join in to take the hackathons in a cyclic fashion, right? So the actual lecture is taken by Rajiv sir or Jain sir, right? So I'm just going to give you an assessment. I can see that in this particular lecture, there was one lecture by Rajiv sir, one by Jain sir, and then one more revision or overview of Python by me. Right. Similarly, all the sessions, these EDA and everything is covered by Jain sir. And as we go proceed forward, people who are in silver, they can also see that the Rajiv sir modules, the advanced modules are also available, which people in bronze can later access. Right. So now this is the structure. So this is how you have to go ahead and access your AI course. Okay. Now, if at all you plan on joining the revision hackathon, you can parallelly do that. You can continue from the beginning and also catch up with what is happening right now, or you can, this revision hackathons happen in a cycle. Once this all completes, like whole of the cycle is revised, and we start from module 1 again. Maybe that point of time you are in third module or something, then you'll attend the revision hackathon, and that goes in a cycle, right? So the intent is to strengthen your concepts, right? So because we have more members who are new, who have recently joined, like Tejinder sir, Vijay sir, when did you join? Like which module you are in? Just
silver.
Yeah, which module, like 4.3, which module you are in?
Right now, in module 1, completed the first one.
Okay, that's really nice, sir. Okay, so we are going to there. We are going there. So another way to go ahead is all the revision hackathons recordings are available in your inner circle, right? So if at all you want to go by the first module, let's say if you're going through exploratory data analysis lecture, and then you want to go through the revision of the same, you can go through inner circle, and towards the end you will be finding the recordings of it, so you can see the actual lecture and the revision lecture, right? So this is how the pattern is going to be for whole of the course duration, right? So people who are not able to access Teachable, I'd request you to go ahead and search for emails from j@pixeltest.com or Teachable. Right. So if this is clear for all the people who have recently joined, right, you can type C in the chat box if it is clear. Right. Thanks, Prashant. Thanks, Raja sir. So people who are on our social channels, use the comment section or chat section. Right. Thanks, everyone. Okay. Now, thank you, Deepak. What we are going to do is, now currently we are revising 4.2, right? So if at all you've not come in the series, okay, Farhana, maybe I'll quickly revise. People who have recently joined can start from the beginning, or continue accessing the revision hackathon also, right? So I'll be, whenever you have a doubt, for example, you are in 1.3 module and you have any doubt, you can join the revision hackathon and bring your queries, right? So if you have any specific query, you can bring that to us and we'll either answer it immediately there or in the next session based upon time, right? So that is how this will go. I hope that answers. Great. So today we are revising 4.2 linear regression. We are going to have a shorter session today. Quickly, will be portion of that particular lecture we are going to revise today. In our previous sessions, we have revised the 4.1, right? So people who have recently joined, do not worry. You can understand the overview of it briefly also. If you understand, that is fine. And then you can start from the beginning. I request you to start from the beginning if you're parallelly planning on to attending this as well. Okay. Great, because then you'll have stronger recall also that the current is also being covered and the previous also. You can always choose to attend the upcoming revision cycle also, but you don't have to wait that much. Great, thanks everyone. And now what I'm going to do, I'm just going to start. So for the people who have recently joined, let's say Every lecture has a video related to it, which is an unlisted private video for you. You can access that by clicking here. And then there is a lecture assignment and lecture notebook. So when you click that, it will open in this particular format. You don't have to install anything here. Okay, so you just have to click on open with Google Collab, right? So when you click on open with Google Collab, you will be able to access that particular notebook, right? So this is where we are going to run our functions. Okay, so don't worry, I'll navigate. If you look at the first module, and we also explain on how to access Collab and everything, right? So that is also clearly explained, right? So you don't have to know like what is this and all. If you are new, you don't have to install Python in your own system also. You can run all of this from an offering by Google, which is called Collab, where you can run your Python programs directly here. Okay, now let us begin. So in our previous session, we have covered 4.1. People who have just now opened this, you'll see that, okay, the link to this I'm also sharing here on Zoom chat, right? So you can open this. It would be good if you are able to join from your desktop for ease of access, right? Sorry. Now I'm just going to share the link here on chat. So the link is there. Yeah, so Rajesh sir, thanks for informing. Do not worry. Please take care there. And whenever you find an issue, you can always reach out or join any of our hackathon sessions and let us know where you're finding any challenge. Okay. Thank you. Thank you so much, sir. Please do take care. Now, I've shared the link also. You can go ahead and use this particular link to access this particular notes. Okay. Now, let's begin. Now, once you connect this, you can see that the title here is the regression to. These are the agenda points, right? The agenda here is we are going to learn something called training a model and testing a model, right? So we are going to do that. Now, then one of the packages of Python we are going to cover, which is the use is this scikit learn. We are going to use that. People who have recently joined, don't be overwhelmed by the new terminology. Once you start from beginning, it will all start making sense, right? Now what I'm going to do is, first I'm going to start here with the import function. So when you do this, it will first create a path. I'm just going to do that. This is like a usual that we do for every session, right? So we have created a variable called data path here, which will have the data set within that, right? So I'm also going to display the data set. Now in this example, what we are trying to do here is, okay, if you see, we have the data set here, right? So this particular data set has a few features or columns, which is year, the incumbent party, and all those things. So we can see that this is an election data set, right? So we are trying to predict what will be the incumbent, which is the current party's election result, right? So this is what we are going to understand here. Now, when you see an election data, there are multiple factors that might affect the vote share increase or decrease, right? So there are multiple reasons. In this particular data set, there are a few particular features or columns given, like the average recent growth in personal incomes, right? So if in any year we can see that there is growth in personal incomes, then that will positively work towards increasing the vote share, right? And if there is like US military fatalities per million, right? So per million, how many people, how many deaths are happening? If that also comes down, that also is going to be a good attribute for increasing the vote share. So these are like, this is the data set. And how did we get this data set? What happened here is in data path, we have this particular file. So I'm just going to paste it here. And then we are reading the CSV, which is data path plus this particular file name, right? So I'm just going to enter that. Now you can see that this is the data set, which is a CSV file or an Excel open file that is now being imported here, right? So if it is clear, like how we have imported a CSV file into Python, right? If you have understood that, if that is clear, type C in the chat box. I'm keeping this session basic for even people to briefly understand what is happening here. Thank you, Venkatrasan. Okay, so people who have recently joined, even if you are understanding briefly what is overview happening, you can continue, and I'd guide you on how to start from the beginning also. Thank you, Vinita ma'am. Thank you, Raja. Right, so we have imported, and now there's more information about the data set here, right? Yes, Rahul sir. So we're going to keep this particular session short. So do not worry, we're not going to complete. We're going to complete portion of this today. Yeah. So now more details about the data source is being is written here. So you can also go ahead and learn more about the data set. The important portions from this is we are going to split our data in two sets. So if you see our previous Collab file or details that we have worked with, the data set when we have worked with, what we had is there is one training data, there is one training data set, and then post that we have tried to predict for a new data set, right? So what we have done, first we have trained the model, and then we give some input, another value based upon which it will predict the price of that particular real estate property, right? So do not worry, people who have recently joined, you can definitely understand this once you start from the beginning. Okay. Now, similarly, in this particular small data set, what we are going to do is we are going to have a training data set. These all data sets from 0 to 13, we are going to use to train our model. And we are going to use 2008, 2012, 2016 for testing the model. Basically, whenever you do some, fixing, right? When you create something, you first test it, right? So it is something similar that we are doing. Like if you get something repaired or something, then while repairing, you do a lot of these things. And once you do that, then you test it if it is running, if the tap is fixed or not, and let it go for some time. All these things you do, right? So similarly, here also we are going to train and test our data set, right, or the model, right? So all the observations that are before 2008 are going to be used to train model, and all the observations after 2008, which is the 2008, 12, and 16, are going to be used for testing, right? So now you can see that from in this data set, the election in US happens once in 4 years, and then for that reason the gap is 4, right? So this is what we are going to do. Now this is also being explained here. 80% of the data we use for training, 20% we use for testing, so that we know that the model is accurate, or is it close, or is it away, right? So this is what we are going to do. Same content is being explained here. The size of the test set is typically about 20% of the total sample. The model which fits the training data will not necessarily forecast well, right? So a perfect fit can always be obtained by using a model with enough parameters, right? So if at all we create one model, here to explain a model, we're going to create a model which will, based upon a new input, it is going to tell how much the party's vote share might increase, right? So it cannot be heavily accurate. So what we are trying to say here is, if, for example, we are only trying to calculate the increase in vote share based upon one parameter, there'll be one type of model, but you have enough parameters, right? So the actual enough parameters, like for example, 2 or more, then you'll have a better model, right? It's a better fit. So that fit we are calling here a perfect fit, where, like for example, in our previous data set, real estate property prices are not just on what you call SFT, right? On the area size, it is also based upon the location, the surrounding, and all the other amenities also, right? So more parameters you add to the model becomes perfect. So that is being explained here. Yeah, so overfitting a model to data is just just as bad as failing to identify a systemic pattern in the data, right? So we're not trying to give in more and more parameters, just enough parameters, right? So now how should we split? Now that is what is being told here. So now we're going into the exercise. So people who have recently joined, this is how Collab works, right? So even if at all you want to do something like a small program, which is like print, right? So if you're going to say print, say hello world, right? Like say today is Wednesday, and if you do it, it is going to run that. Okay, so it's very easy. We have covered it in the beginning sessions. Similarly, there are some complex functions here. It is very simple print function. Now there are some complex or I not use the word complex, some some functions which we are already used. Maybe for you it might be new right now, but once you cover from the beginning, it will be easier, right? So especially from the people who have recently joined, if you have understood that you can start from the beginning and be able to reach here, if you have understood that, type you in the chat box. People who are joining us from our social channels, you can also type in the comment section. If you understood that, you'll be able to do this. If you start from the beginning, then type you in the chat box. Great. Thanks, Suraj. Thanks, Lakshman. Yeah, anybody on the Zoom session? Great, okay. Okay, so people are sending messages directly. You can mark it to everyone. That is also fine. Okay, thanks everyone. Now, so what we are doing is we are saying all the data records or observation that are less than 2008, year 2008, save it into a variable called train, right? So just to explain this, I'm just going to, show it here. What is there in this particular data set, right? So now what is DF here? You can see that data frame, this is the data frame that we have taken. In this data frame, you have all of this data that is from the CSV. This whole data set is in DF. Okay. Now, out of that, when you say DF of year, it is going to say in this data frame, the year column. Now, when you run it, it is going to just give you that particular year column, right? So all the records in that. Now, what you're saying, wherever the year is less than 2008, all of those records, save it in a variable called or data frame called train and test, right? So now we have created two data sets, right? So wherever it is less than 2008 and greater than 2008. Okay, so now we have done that. Now, if at all we want to see how many observations are there in this particular train and test data set, you can just add dot shape to the name of your data frame variable, right? So when you do that, it is going to say 14 by 6, meaning there are 14 rows from 0 to 13, meaning 13 plus 1, 14 rows and 6 columns, right? So that is understood. Test dot shape 3, 6. So we have understood the observations, dimensions also using the dot shape, right? Now, what is that we are going to do? We are going to train the model right now. Okay, so now we are going to use this scikit-learn for trying to plot and understand more features about this, right? Now, what we are doing here is first we are going to do the mean of all the party vote share, right, from the train data set. So if you run that, okay, so what will happen? You can see that the average or mean of all of this train data set is 52. Now, what if we guess this number for every election? How far off would be from the average? For example, if it is 52, now in some records, you can see that it is 44, it is 49, it's 57. So what we'll do is we'll try to minus that particular average from all of these records and see how much away are we from the mean in each of the observation, and get an average of how much error or how much difference is being created there. Okay, so now let us go ahead and do it. Now what we are doing here, we are creating new data sets. So I'm just going to run it, which is called y-train and y-test, right? So for the y-axis, okay. So I'm just going to click that. Now you have created them. So I'm just going to print it here for understanding. y_train. Okay, so now if you see, all of these incumbent party vote share, the column, whatever is there, that has been copied into your new data set, which is called y-train, right? So which means from this 44 till 2004 with 51.24, all of these observations have been copied into your y-train, right? So this variable. Similarly for y-test also, right? So if you see y-test, if you run it, yeah, so it has 3 observations. Okay, now what we are trying to do, we are going to do a mean baseline. I have told there is a mean, and we are going to see how away from that we are, right? So we are creating a variable called guess and doing the mean of the 3 observations, right? I'm just going to do that. Okay, so though now you can see, okay, so this is not getting printed. I'm just going to say print guess. Okay, so the mean also here is roughly 52.46. Yeah, so we have got that. So that has been created for the train, right? So whatever guess here it was, we have copied that into a guess. Okay, now we are going to do the train error. So what we are going to do, we are going to run this from, we are going to import a library, which is the scikit-learn, right? So importing from libraries has been covered in our previous sessions. So that also, if you are, have any confusion, you can go through that. Even right now, if you're briefly understanding also, that is fine, right? So that is what we are going to do here. Okay, so importing, the question being asked is, what is like importing? So basically, let's say if you have to use a word from any new language, you should first know the language, right? So basically, for example, you want to use one word from Hindi, given that you need to know Hindi, right? So import means that all of the words in that Hindi language are being taken into your program. And whenever you use a word, because you imported that particular language or that particular library, you'll be able to use it, in proper way, right? So when you're training Google language, translation and all, that is how the libraries and all those things happen, right? So this is like a brief idea. In Python, there are multiple ways to import multiple functions. For maths related functions, there are separate. For graphing, plotting, it is separate. So I hope that helps. Right. So now similarly, we are using for our training and testing of the model, we are using one particular library, which is the sklearn. And from that, we are going to just import the mean absolute error, this function. Okay. So now what we are doing is we are creating a new variable, which is the y prediction, which is whatever was guess in the guess into length of the y train. Here train is nothing but training, the data set that you have created, and y prediction, whatever is there, it is being multiplied by the length of that particular train, right? So create a data frame with the baseline guess only, right? So I'm just going to run this. It will become easier. So the mean absolute error between the Y train and Y prediction is going to give us the difference, right? So I'm just going to run it and you'll be able to understand what is happening here, right? So if you see this, the train error from 1952 to 2004 elections is whatever is there in the data set, in the variable MAE, which is mean absolute error, which is 4.85 percentage points, right? So this is what is in percentage. Now what we are trying to do here is, I'm just going to first comment this and print Y prediction here, okay? So it will become easier for you to understand what is there in Y prediction. Okay, so now if you see this Y prediction, what it did is, whatever guess that was created, it multiplied it with the length and how many ever are there in that particular length. Like there are 14 rows. So 14 elements are being created in this Y prediction data frame, right? So there are 14 similar values that get created. And now what we are doing is, when you give mean absolute error the function, you have to give them two data frames, right? So one is the Y train, which is the actual data set, and then the other one is the prediction, right? So the prediction multiplied, which prediction has the guess in it, right? So now when you print the absolute, use this function mean absolute error, so you need not have to know what is the math or logic behind the mean absolute error. You just have to pass the actual data set that you're using for training and the other data set which you're using for the prediction. So when you run that, it will auto calculate the error and then save it in the variable that you are using. Okay, so which was 4.85%. So what new we have learned here is, the mean absolute error is a function which is going to take inputs, the training data set and the prediction data set, and going to give you the mean absolute error, right? So now 4.85% is the mean absolute error. Now what we are trying to do is, now we are going to do the same thing for test also, the three observations that we have. And for test, we have the mean absolute error as 3.63, right? So this function is like any of your other functions like average, sum, or something like that. But this is given for a specific use, which is the average absolute error. Yeah, so no, sir. So basically, correct. Okay. So now let me go ahead and try to print this. Now, when you see this guess, we are putting this into our column, right? So I'm just going to break it down into smaller steps for everyone to be on the same page, right? Okay. Here, first, I'm just going to print the guess data set. I'm just going to see if this is going to work. The data frame. So now what is the guess? The guess is 52, and you're doing a matrix multiplication kind of a thing here, right? So when you're doing into length of Y train. So now what is the length of Y train? Okay, I'm just going to map all of it here so it becomes easy for you. Which is 14, right? So now we have our guess. Now we have our 14. Now guess is this is in square brackets, meaning which is still an array or the data frame. When you multiply it by 14 and save it in Y prediction, so because the mean absolute error is going to take a set of data, it is not going to take one value. Now, what type of data is Y train? Now, let me go ahead and print Y train. Okay. So I'll just try to run it here. What is Y train? Which you have created initially, right? So I'm just going to print Y train. Now Y train is all this data set. Now let's just say if you want to multiply or do any operation of a data frame or a data set, a column like this with a value 52.46, it will be in a different format. So this is a column and this is going to be a single variable. So for that reason, what we are doing is we are converting this into a a column of same element every time, so that you can give y train and y prediction as an input, where each of the elements in y train is going to be the actual value that we have taken from the data frame, the actual data frame, and y prediction would be same 52.46 14 times. So the operation is happening cumulatively on this set and that, so that the input taken by the mean absolute error formula is going to be 2 columns, right? So I hope this answers your question. So why are we multiplying it? Because you want a column that goes as a matrix which is corresponding to the y train. Now we have 14 elements in this, and in y prediction also we are going to have 14 elements. Now it is easy for you to put them into the function mean absolute error, right? So now, yeah. Yes, Venkatraw sir. So that is how the prediction is happening. Now, if at all, for example, there were 5 elements in the train, you are going to have this 5 guesses in that particular column. I hope this answers the question of both Anita ma'am and Venkatraw sir. Thank you so much, sir. Thanks for the question. Yeah, so now this is why we have given, because like, for example, if at all you have a function which is taking a similar type of inputs, right? So that is the reason we are going to use this multiplication here, right? We are just converting it into a longer data frame. So that is the reason we use the square brackets to convert into data frame. Yeah, so I'm Vinita ma'am. Is it getting multiplied with 14 or y train values? You're talking about the y prediction, madam? Okay, so if you see, let me just go with matrix multiplication. Now, if you see this simple matrix multiplication, whenever you have a column multiplied with value, each of it gets multiplied and you have a column once again, right? So I'm just going to, yesterday, if you in our previous session, if you see matrix multiplication of one column with one number, right? I'm just trying to see if you will have a particular simple example. Yeah, so now what is happening in this particular example is one row, so one row, one column is there. Now let's say you're doing guess with one number. So here you can see there are a row by column, but what if there is only one element in that particular data set? So when you're doing here, the matrix multiplication is happening. So now what I understood is, like, maybe you're thinking, is the multiplication, how is the multiplication happening? So now you can see that here, y prediction is going in this particular format and creating a new data frame, right? So I hope that answers your question, Vinita. Okay, so if that is okay, cool, we can go forward, or let me know. Yes, definitely. We'll just go forward and see y underscore prediction, which is something similar. Okay, so now y prediction, because we have taken it for the train. Okay, so same name we have used here, right? Okay. So here, because y test was here, we have taken the same inputs. Now, if I run it from the beginning, you'll be able to see that there are 14. Yes, Vinita. it is getting multiplied 14 times. Yeah. Okay. So we are good here. I hope this is clear. Yes, you are getting the same value. If you remember in our previous session, we have done something similar with the unit matrix, right? So if you remember, we have done an identity matrix. I'm not sure if it was 4.1 or no, it was 3. Module 3 in our previous sessions, we have did it for a single column. Okay, so let me just see if we can see it was 3.3. Oh, well, I think it was 3.4. Yeah, so this is where we created even the unit matrices in a similar format, right? Yeah, so here this is where we have created these matrices and everything, right? So whenever you want to create a new matrix, you can either, if it is a matrix addition, you can directly create one single value, add it, or you can do it in this particular format, right? So I'm just trying to look at the actual unit matrix example. Yeah, I think this should also be good. So now what we are doing here is when we are creating X, actually in this particular data set, 3.88 was the value that was the nitro value, right? So now which we are taking as X, but because we wanted Y multiplication with X, which will be like this. So 71.8 into 1. So this into this, right? So Y is equal to mx, right? So what is M here? M is going to be the value, which was the intercept, right? So the intercept was 36, I guess. Yeah, so now if you see here, this multiplied by the coefficients, right? So it is going to be 1 into B0 plus 3.88 into B1, right? So similarly, you're going to get this particular value. To get this such a value, we had to add ones here, right? So this is what we have done previously. So to bring it that into this particular format, we have used this particular, casing. Yes, I hope it is clear now, Vinita. Okay, so because we have multiple files, yeah, if at all I was to write, I would just write it here and it would be easier. Okay, so now mean absolute error is going to take in this particular format only, where you're multiplying it with the guess with the length, and you're going to get another data set, and you're going to give both of these data sets as an input to the mean absolute error, which is going to directly give you the average error that is coming in that particular data set, right? So now you can see the actual prediction and training data sets mean absolute error values you have got. 2008 to 16 elections, it's 3.63, and the mean absolute error here is 4.85, right? So now this is a regular mean absolute error, but let us go a step further and see if we add one single feature, how this is going to happen, right? Now, what we are trying to do here is, people who have recently joined, this also we cover in our previous sessions, where it is about importing. Similarly, you are going to import a library called pandas and plotly, and then we are going to do a scatter plot, which is a plot like this, where it will scatter all the points that we are giving as an input. So now what inputs we are giving to it is the train that from that data set, X being the column average recent growth in personal incomes, Y being the party vote share. So the party vote share against the growth in personal incomes, right? So when you do that, year over year, it has increased. Some years it has been higher, very high increase. Some years it's been lower. But what we are trying to do here is, we are giving a trend line, which is the OLS, which is going to be kind of an average or an estimated line, which comes between all of these values, right? So this is the line that is coming based upon all the scattered plots. This is a line that is closest to all of them, right? So now this is what we have done. We have added all of these. Now you can, in this particular type of scatter plot, you can see when you hover on each of the point, it is giving the average growth at that in personal incomes and the year at which that happened, also along with the party vote share, right? So the text is also being mentioned here, right? So now this is all covered, right? So what is text doing, right? So X and Y are the only rows and columns here, but when you are writing text as year, you can see that when you are hovering on it, you are able to get all of that here, right? Title is nothing but what it has to come here that has been mentioned. So you have plotted a nice graph, which is giving you a trend line. Now, if at all you want to, understand roughly what would be an estimate, let's say I'm just giving a hypothetical case, what would be an estimate for this particular average growth, right? Or what would have been a vote share, right? So now you have a plot based upon which maybe you could have said like this would have been the vote share increase. Now this is random at this moment, but now the model is using the logic of it is there already in the model. So it is using such an estimation to give you a value back, right? So now we're going to go in detail to understand it. So there are 5 steps of process that we have done in a previous session also. In our real estate data also, we have done these 5 steps. If you remember, which is step 1 to step 5, we're going to do some similar thing here. First, we are going to import the appropriate estimator class from the scikit-learn, right? So which is going to be a library and a function. We are going to import the linear regression from that particular library. And we are going to do our model in the data frame model. We have instantiated that class. And then what features? Features are nothing but the columns that we are giving the model for training, right? So we are going to give train. So we are going to take the feature as the column, average recent growth in personal incomes, right? So now if you can see that there is square brackets, which is telling us this is a column that is coming in. And now the X train, right? So we are going to also create the features, the X train, which is nothing but from the variable train, we are going to get features, meaning it is going to be nothing but train of this column. And now we are going to save it in X train, right? So this is also we have taken. Now we have got our X. X is nothing but the average recent growth in personal incomes is already in this particular data set. Now, similarly, we also have something very easy for X test also. Features is going to be the same column in the test data set. Whatever 3 values we have, all of that are now being saved into the X test, right? So we also have both of the features ready, right? Now, what we are doing here next, you can see that when you print linear regression model, dependent upon the feature, right? So here, what is the feature? Average recent growth. So there's nothing fancy here. Yeah. Now the most important step, which is the fit model. You're just going to use dot fit on the model that is created with variables X train and Y train, right? So now you are giving these inputs to this particular variable, right? So if at all you want to see what is there in X train, you can see X train, we have these averages, and in Y train, we have these data sets, right? Okay, so if you see, we have used Y train before also, sir. Right, I'm just going to say Y. Sorry. Is your question on how this data got split, sir? Like maybe you can explain that clearly. If your question, as I understand, is how did we get the Y train? You see, we have created initially the Y train as train of incumbent party, right? So we have already done it in our beginning, like the beginning of the session only. So now the Y value is the vote share, For training data, it is in y-train dataset. In testing dataset is y-test, which is nothing but test of the vote share column, right? So I think, yeah, that's clear. Now we have given that same inputs to this particular model. Yeah, Raja sir, mostly it is 80-20 split between the training and testing data set. Yeah, it could vary from case to case, but this is like a standard. Okay, so features is nothing but, sometimes here you can directly use this particular name, right? So you can directly use directly the average recent growth here. Like for example, now if you give it like this, that also should be fine. But as a standard, we write features because when you are actually building models, there could be more features. So for that reason, we've just taken it first into a features variable. Yeah. So now our data on the x variable, on the x-axis there. So now we are going to actually go ahead and run the prediction on the same. Okay. So I think I have understood what has happened because we use the same variable names and we are using it for all of it. I'm just going to run all of it from the beginning. Okay, so we are here. Just keep it. Sorry, it went till the end. Yeah, so we are here. Yeah, so now what happened? We have given the inputs to the model and that have been created here. And then because the model is created, the system has a model now. Now we can ask it for prediction, right? Now that what we are saying is now that you are aware about all the incumbent party vote shares when against the average recent growth in personal incomes, I'm just going to give you another value. Can you go ahead and predict something, right? So now what we are going to do is do the y predict, and here we are going to give the use the dot predict function here. When you are going to predict, use the dot predict function, you're going to give the x training column as an input, right? So now that is there in the prediction. So the model is going to predict it and save it into the y prediction here, right? So I'm just going to also print y prediction for us that we are clear, right? And whatever y prediction is the model is giving based upon whatever training data we have given, that we are using in our mean absolute error, right? So y train against y prediction, training and prediction, so that we also have a prediction and we also have what error it could be, whatever error that prediction could be. So we are trying to understand, right? So now let me see if we are to print y prediction. Yeah, so okay. Some reason when I use print, it is not printing in a column view. Okay, so I think the model.predict gives output in an array format only. So based upon each of the data set like that is given, right? So now you see what is there in X training, right? Each of the, all of that training data set that we have here in X train. Where is our X train? Okay, so I'm just going to print that also here for us to clearly visualize. X underscore train. How are we going to run this? Yeah, so our training data has this, and we have given that as an input to our prediction, right? So when we have given that for prediction, it has given us a prediction and it saved that for these X values, you are going to have the vote share, right? So what is Y? Y is the vote share, right? The incumbent party vote share would be predicted to be 44 for this average recent growth and this fatality, these number of deaths per million for this set of recent growth in incomes along with the corresponding fatalities, the prediction would be this. So it has given a prediction like that. And now the mean absolute error also has given how much could be the error. So it says these are the predictions with an absolute error of 1.33%, right? So now you know that if you give some values in X train to the dot predict function of the model, you will get a prediction. And now by using the mean absolute error also, you can see that how much error there could be in that prediction, right? So now this is what we have done in this particular session. What I'm just summarizing in this particular point, we have trained the model giving the all the data sets, all the data frame, whatever we had. Based upon that, we asked it to predict something, and it predicted and also gave us the mean absolute error for that, right? So if this is clear, type C in the chat box. Thank you, Venkatas. So I'd also request you to go through the actual, go through the whole of the details, whole of the Collab file by yourself, so that becomes more and more clear, because these functions will not be, strengthened. The recall will not be stronger if we just see. You have to run the function, run into some errors, and then you know that, okay, this is how it will work. Right? So when I run into errors also, it is becoming strong. Okay, so Vinita ma'am, right? So first what we have done is we have done a simple linear regression, and then we have also taken multiple inputs into that. So for that reason, it has run. Okay, so now if you see here in the fifth model, you can see that there are two data sets in this particular regression. So multiple regression. What happened is we have taken two inputs, right? So those two inputs, so what happened is when I printed the X train, it printed the last saved value. But if at all I have to print the X train that we have taken here initially, like for example, if I'm going to run this and then run this again, you can see that this is what is there, right? So what happens in this Collab files I have seen is all the variables, even if it is used for single linear regression, multiple linear regression, the names are same. And when you run all of them together and then print it somewhere, it will take the last saved value into that. And so that is the challenge. So now I have went back and run that. So then there was this input that just taken. The concept remains the same for multiple regression. So we'll see that now, right? I hope that answers me. Yeah, so similarly, we can apply that to a new model, new data also. Now, what we have done, earlier we have given the training data set. Now we are going to give the X test, and for that X test also, it is going to give a prediction and tells us what could be the mean absolute error. Right, so the predictions are not being printed, so I'm just going to print the Y prediction now. Right, so yeah, so these are the predictions for the X tests, average recent growth in personal incomes, right? So this is what we have done for single variable, right? Single X axis, right? Now what we are trying to do is we are going to include one more variable so that the model becomes better. Yeah. Yes. So I see Ravi sir, your question. So I'm just sharing the details with you. Yeah. Now you can always reach out. Really nice to know all the details that you have shared, sir. So because I think you have joined in late, you can actually go through the recording of the same as well. It is also there in the same email. But if you've recently joined, I would request you to start from the beginning, right? So I have told, in the beginning of the session, I have briefed on, how to access all of your lectures from the beginning, right? So you can start from here. Yeah. So maybe what you can do is, Ravi sir, you can share your contact so that the team can reach out, right? If you have an international number. Cool. Okay. So now we have given one input. Based upon that one input, we made a model. But if you remember in our previous example also, we had like real estate will not depend on one variable, or the election growth vote share will be dependent on one variable. So we are going to add another variable to see if we are able to get a better or a perfect model. That is where the multiple regression comes, where we are using two features, right? So X is as it is the average recent growth, and Y is now the other column that we have, which is the US military fatalities or deaths per million, right? Now, Z here in our previous case, it was Y axis and X axis. Now, your party vote share is in your Z axis. So it's going to be a 3D model, right? So till here, we had the 2D model. Now we are going to plot a 3D to understand better, visualize better, right? So understanding is anyway there. So now you use the function scatter underscore 3D. It's also to show you that how these functions work. So you need not actually have to have a always use a 3D. You can always use the data set also to understand, right? So now the scatter gives you a very good graph, which you can kind of tweak with, understand if at all you are into data visualization understanding. If at all you're trying to see, okay, sorry, my screen is not visible. Yeah. Okay. It is a little tricky to work with this. Now, what we are looking at here is party vote share. Okay, I think it's a little gamey thing, right? Sorry for my mouse movements. I'm just going to leave it at how it was there, and so it becomes easier. Yeah, so this is the graph. Now you can see that the three on x-axis, okay, we have average growth in personal income. On y-axis, we have our US military fatalities. On Z, we have our incumbent party vote share, right? So wherever you want to see that particular area, you can see that is visible here. 3D is definitely a little difficult to interpret, sir. Yeah, thank you, Radha, sir. Yeah, so it's, but then there is a plane that you can draw. So it's also good to know if at all somebody asks us to plot a 3D, you know what to use now, right? This is scatter underscore 3D. Now, what we are trying to do here is we are using the features as average growth and the fatalities. And now we are going to give the X underscore train, right? So if I were you, I would be using a new variable, let's say multiple regression, right? So that your X train does not get disturbed, right? So X test underscore multiple regression, right? So now you can kind of work with that particular data set, right? So now the linear regression currently is being worked on the average personal incomes and the US fatalities. Now here we are going to give these data sets for the model fit. We are going to do the fit model. Did I underscore MR underscore MR? I did the same, right? Okay, so for X train, it is still the same, right? So X training model is going to remain the same. So I'm just going to run that. Yeah, so the linear model is because I have actually only created the X train and X test. The Y train is all, the Y axis of the train. Basically, the incumbent vote share, percentage vote share is going to remain the same. So I'm not using it. I'm not changing it, right? X train was for the multiple regression was underscore MR. Now, if you try to make a prediction based upon this model, based upon the xtrain underscore MR, and then you kind of get your, mean absolute error, you can see that it is also going to print your mean absolute error. You can see that the mean absolute error is still 1.33. And if you want to calculate the mean absolute error manually also, there's this function, right? So you don't have to use this. You can do whatever is y predicted minus the whatever is y train, right? So all of that minus into the absolute function dot mean, right? So if at all there was a negative value, the absolute will make it positive, and dot mean will give the average of it. Basically, here we are getting the average mean. So error, right? So absolute mean absolute error. So we are getting mean here, and we are getting the error here. So we are also getting the absolute using the dot abs function. So if at all you want to do this manually also, you can use this difference absolute of it and mean of it, which is also going to give you the mean absolute error. So you can see that both of it is the same, right? So this is how we have understood, we have trained our model, and we have seen that the mean absolute error also we are able to calculate. Okay, now what we are trying to do is we are going to give the X test, right? So the multiple regression, whatever data set we have created, I'm going to give it the X test as an input here, and then calculate the mean absolute error here, right? So now for training data set, for test data set, we got the absolute error as 1.6, and for the training data set, we got the absolute error as 1.3, right? So now, if at all we try to compare in our previous case, what was our previous absolute error, right? So you can compare it with our previous absolute error. I'm just going to figure out where it was. Yeah, so earlier it was 1.33. So pretty much same points that you're getting, right? So the absolute error is almost all similar, right? So this is what we have done. So even in a little bit points also, if at all you are trying to see that there is reduce in error by having a better in another column, another feature. Multiple regression is about two features, right? Earlier we did only for average personal growth, and now the military fatalities also. You can see that if the absolute error increased or decreased, based upon that, you can compare with our previous model, single linear regression, and then see that if it's a better model or not, right? So this is what we have completed. Now, this is how you train a model and you test your data set. And based upon that, you make a prediction, right? So here, for some reason, the prediction is not being printed, but that is one important thing that you want to see, right? So for the X test data set, given the current fatality and the personal growth in incomes, you can see that this will be the predictions, right? So now I'm just going to copy this and go here and see this was the Y prediction for our previous set, right? So I'm just going to, okay, sorry. Did I run it here? Just going to say, paste it here, comment it. Now you can see the prediction was almost all similar, right? Was that the prediction? When I ran it, did I change it? Okay, so this was the prediction that was there. Let me see. So I'm just going to name it differently. Underscore MR underscore MR. And see, okay, this is clear. Now what I'm going to run here is X test, Y test, and Y prediction, right? So I think they should give the actual values. Okay, so now you can see that the prediction is more or less, this is the exact one. So actually adding another variable. So this is what we wanted to see. The model as is that was created previously was good, which tells us that the US military fatalities per million is not affecting the person winning or losing or increasing the person vote share. So that is what is what I can infer from this. Right. So if this is clear, like how to run a multiple regression, if this is clear, type C in the chat box. Thank you, Venkatraman. So this will become clearer as we do practice. So I request everyone to go ahead and try to train your models, fit your models, and then test your models, especially whatever is given in the session. And then you can actually go look at online data sets also and try to use those data sets to learn more about model fitting, right? So the more you work with training models and working with predictions, it is going to be that useful for you, right? So I request you to encourage you to go ahead and work on more data sets as well. Great. So this is what was covered for today's session. We are going to learn more as we proceed forward. I think Kaggle is something that you have seen, ma'am, and maybe I would ask you if you found any websites for such data sets. One of the data set that is there for the Pixeltests, right? So you can see that on the GitHub library, the data sets of Pixeltests, whatever are ideal for you to use, all of them are listed. I'm just going to point you out there, right? So all these data sets, a few sample test example data sets are here, right? Okay, I have to, I guess, to github.com. Yeah, so you can see a few data sets are here, and how to find the link of each of this is the same way. You can go to this, replace the github.com with GitHub user content and use this file name. You'll be able to use these data sets. A few of them have been already previously used, but if at all you want to use the same, these are available. But there are a lot of other sites. A little search, you'll be able to find it. And I'm just going to share this with everyone. Yeah, so you can use these data sets to train your model. Prediction, maybe you can create a data frame, give some random values and see how the prediction is. What you can do is, like, if it is a real data set, you can use only 80% of the test and then give the 80% for training and 20% for testing, and use those tests and see if your prediction is coming closer to any of it, right? So that will also be helpful. Great. So I hope this session was clear. So people who have recently joined, do not worry. Wish you all a very happy Holi. So thank you so much, Radha sir. Yeah, thank you so much. So if at all you recently joined, do not worry. All of this becomes clearer as you go into our previous modules. If you face any challenge, you can always bring those problems to the hackathon session as well, right? So I request you to go ahead and go through the actual lecture. Even if you're missing anything, all of this, whatever we have covered, is actually explained in this lecture video that is there, right? So now whatever I have taken, now you can see this is for confidence of people who are just now getting. Now you can see that the same sets of data has been explained and everything has been done. Similarly, it has been done for all of the previous sessions also. So if you missed anything, do not worry. Go start from the beginning. From there only we're going to revise, right? So if you start from the beginning, you'll start from scratch. I hope that is clear. Okay. So thanks everyone for joining in. If there's any query, you can let me know. If everything is clear, type C in the chat box. Once you practice, if any problems come in or if you feel that something missed, you can bring it to our session again on Friday. Thank you so much, Radha sir. Thank you, Venkatraman sir. Amazing then. Thank you, Vinita ma'am. Okay, then see you all in our next session. Thank you.